Hi, in this video, we're going to take a look at PAT, Port Address Translation, also known as NAT overload, and a couple of other things as well. Theoretically, so we're using, as you probably can tell, we're using UDP and TCP port numbers. We'll talk more about that in a moment, but which is a 16-bit uses 16 bits for the port number. So theoretically, we could use over 65,000 or 65,536 possibilities. But really more, usually it's in the hundreds or just a few thousand devices can be translated using a single public IPv4 address. Okay? So what we're talking about here is we can have hundreds, even thousands of private RFC-19 addresses being translated to a single public IPv4 address. And this is really what has saved IPv4 over these number of years. Okay? All right, so let's take a look here. So how do we configure this? All right, so what we do is it's very similar to dynamic NAT. And actually, let me just go through this. Yeah, very similar to dynamic NAT. So let's do the easy part first. Serial 000. This is our IP NAT inside network. Serial 010. IP NAT outside, that's the outside part of our network of translations, right? Inside and outside. Okay, IP NAT inside source list. We've seen this before in the previous video. This refers to this access list. So anybody beginning with a source IP address of 192.168 can get translated. Okay, it's going to use a pool called NATPOOL2. Here's the pool. NATPOOL2. Here's the range of addresses. Okay, nothing different. Now we say prefix length, that's like a /27, or we could have said net mask and given us a subnet mask in dotted decimal. Either way is fine. Everything is exactly like dynamic NAT. Here's our range. Okay, from first to beginning to the ending. Here's the difference, overload. We can overload every one of these addresses with multiple inside addresses. Okay, let's take a look at how this works. So a single public IPv4 address can be used by hundreds and even thousands of internal devices. Okay. All right, let's see how this works. Okay, so we do show IP NAT translations here. So let's take a look. If I have this device here, 192.168.10.10. Okay, so here's its source device, here source address 192.168.10.10. Excuse my poor writing here. Destination address. So let's say we're trying to reach, let's see, where are we here? 10.10, it's trying to reach this web server here. Public address. So I'm just going to put 209 ... because it's a public address and it's not going to change, .1. Okay, so source port. Okay, so it's using a, destination port, let's say is port 80. And the source port is, so created by this device, 51839. Okay. So when packets come in, well, first of all, so this is being translated from this source address. So everything else remains the same destination address. Destination port 80, source port 51839, and it's being translated from this address to the public address 209 165.200.226. Okay. Now everything is going to be translated. So you can see that PC2 is also being translated using the same public address. Okay. The way the router is keeping track of when the packets come back in is based on these port numbers. Okay. So in the NAT table on the router here, it's going to know that it translated this source address, 192.168.10.10, to this public IP address, but using this, and this was the source port. So let's take a look at when the data comes back in, that it actually translates it back. So let's take a look here. Might have to rewind to look back, but let's take it back the other way. Okay. So we have the destination address is now the public address that the information was translated to. I probably should have. Oh, I don't think I did the. Let's see here. I can just go back here. So this was the public address. Here's the port number. What I'm going to do here, I'm going to do this real quick. Oh, I did it already. All righty. Sorry about that. I thought I had that table up. And I do, right there. Okay. Let me go back to, sorry about this. I should probably reshoot this video. There we go. All right, let's do this. There we go. There we go. Okay. So sorry about that. So here's the 209 address, 165.200.226. That's what's coming back in. It's coming, the source address is this address here. Okay, source port, port 80. Now the destination port was 51839. Okay, so that was this port number here. So when it comes into the NAT device here, it sees the destination port 51839. That's a 5. Let me make that a little bit better. That's a 5. It says, oh, that that gets translated back to this private IPv4 address. So it knows to translate the destination address gets translated to this private address, the 192.168.10.10. Okay. So using this port number, it knows that, for example, when packet comes in for the same destination IP address, but destined for PC2, it sees its destination port is different. So this destination port would be different, 42558, and it would know to translate it from this address to this address. Okay. Now I've got down here, what if they're the same source port numbers? Would that create a problem? Well, yeah, that would create a problem. So what if both PC1 and PC2 were using the same port numbers? Okay. So what if this port number here is actually 51839? Okay, there'd be no way for the router to differentiate when the destination port is 51839. Which device is it? Do I translate this address? I'm sorry, translate this address or to this address? Which one? They're both 51839. In these cases here, what the router or NAT device will do is say, oh, I've got a duplicate. Before that packet even goes out, what it would do is it would translate this from 51839 to some unique value in the table. Let's say 11111. Okay, so it would actually change the source port going out, And that way, when the destination port comes in for 11111, it would say, oh, that's 11111. That's really not 11111, although that tells me what the IP address is. But when I translate, I won't just translate the address, the destination address. I won't just translate the destination address from this public address to this private address, but I'll also translate the port number to be the right destination port number, 51839. So it'll actually do two translations. It'll translate the destination address from the private to, or from the public to the private, and it will translate the destination port to be the one that it used for it to the one that is actually being used by the client. All right, hope that made sense. If not, I'll be doing more videos on this as well. Okay, verifying PAT. Oh, that looks a little messy. I actually had, let's see, I've got something better than that there. Let me go back to that. Boy, I need to reshoot this video. Okay. Here we go, verifying PAT. Sorry about this. Okay, so we can see it's a similar IP, show IP NAT statistics. We can see the NAT pool being used, the start and end, number allocated. Okay, so similar information. Okay, just one last slide. Sorry, I should probably reshoot this video, and I will at some point. But what if we wanted to use this address as the, let me show you a moment, here we go. If we wanted everything to be translated using this address, the actual IPv4 address of the public-facing interface, okay? So we say IP NAT inside source list. So again, here's our access list saying who gets to get translated. Interface serial 010 overload. So interface 010 and overload. So we're saying we're going to use this, our public-facing IPv4 interface, as to be translated. It's common in small networks that this is the only public IPv4 address you get, is the one that's facing the provider. You don't have any other address space to do the translation. And that's not a problem. You can just use the interface serial, the serial interface, and just say overload. All right, hope this wasn't too confusing. I'll reshoot this video at some point.